Right, we're going to prove a couple of identities here. So the technique is to choose one side, do things to it, and then hopefully end up with the other side. In question one, I'm looking at the left hand side, looking at the right hand side, thinking which side shall I work on, and then simplify and try and end up with the other side. Now looking at this left hand side, I think we could use the difference of two squares here. We could also convert cosec into 1 over sine and cot into cos over sine as well. That starts creating some fractions for us. So I think I'm going to start with the left and try and work towards the right. It's probably possible to do it starting at the right hand side as well, but I'm going to start with the left. So I'm going to rewrite cosec to the power 4 theta as 1 over sine to the power 4 theta. And I could write cot as 1 over tan, but I'm better off writing it as cos over sine, in both cases to the power 4, because we had cot to the power 4. I'm doing this because of our common denominator here. So let's combine these two together. Or I meant to put at the beginning left hand side is. So left hand side is, and then my first expression, and then keep working at it. So I've got common denominator of sine to the power 4 theta, and in the numerator 1 take away cos to the power 4 theta. I said at the beginning, I've noticed we've got the difference of two squares. I could have used it immediately at the beginning, or I could use it now. This numerator will factorize. So this numerator, using a difference of two squares, which helps us factorize things like a squared minus b squared, becomes a minus b times a plus b. So here I've got 1 squared, take away cos squared, squared. So 1 and cos squared theta are my a and b. Makes sense to check that before we move on. So imagine expanding these brackets. Do we get 1 take away cos to the power 4 theta? The answer is yes, we do. Therefore it's correct. Now in the numerator we've got 1 minus cos squared theta, which I could replace with sine squared theta. That's what I'm going to do next. So the first bracket is sine squared theta. Now I have a common factor in numerator and denominator. Got a common factor of sine squared theta. So I'm cancelling that common factor of sine squared theta. And now I'm just one step away from the right hand side. If I look at the new denominator, of the right hand side, it's 1 take away cos squared theta, which is the same as sine squared theta. So denominator 1 minus cos squared theta, which is the right hand side, and that's part A done. In part B, once again I need to make a decision. Am I going to start with the left hand side or start with the right hand side? Looking at the left hand side, we could use the difference of two squares and factorize it into sec theta take away cos theta times sec theta plus cos theta. However, after that I haven't got any ideas what to do next, other than maybe turn sec into 1 over cos, perhaps. I've got a feeling that the right hand side is the easier one to work with here. That's what I'm going to do. I'm going to start with the right hand side and start by expanding the brackets. It's usually easier when you're doing a question like this to get rid of brackets than it is to introduce them. So expanding the brackets. That's all I've done on that first step, expand the brackets. Now I'm going to rewrite sec squared theta as 1 over cos squared theta. I've not done anything to the first term here, But now I've got sine squared theta times 1 over cos squared theta, which is sine squared theta over cos squared theta, which is tan squared theta. Now I don't mind seeing tan squared, because if I remember the left hand side, which is what I'm trying to get, the left hand side has a sec squared. And it's easy to switch between tan squared and sec squared. There's an identity that links those. Also, there's an identity that links sine squared with cos squared. So now looking at the left hand side for ideas on what to do next. So sine squared can be replaced with 1 minus cos squared. And on the right hand side, I'm just going to write the identity that I'm about to use. 1 plus tan squared is always sec squared. So 1 plus tan squared theta is the same as sec squared theta. That allows me to replace tan squared theta with sec squared theta, take away 1. That's just a rearrangement of this. And then 1 take away 1 is 0. And I'm just going to put the positive term first. Take away cos squared theta. And that is what I was aiming for. That's the left hand side. So there are many, many ways of doing those identities. So long as you don't make any massive jumps from one line to the next. Show every step, every little bit of working out. Doesn't matter whether you work from left to the right or right to left. There are many ways of doing it. That's how I would do them.